Hello students, in this video we are going to look at the non-linear optimization models and their solution. So far we have seen linear programming where our variables are in linear format, but here our variables will be now having powers. It can be a positive power or it can be negative power. For example, it can be if our variable is x, it can our equation somewhere either in objective function or in constraints, it will assume power of x raised to minus 1, x raised to minus 2, or it can be also x square, x cube, etc. So which qualifies for your non-linear model. So there are various applications here discussed here. The par problem which we discussed earlier, golf bag problem is discussed here, constructing an index fund, Markowitz portfolio model, blending the pooling problem, and forecasting adoption of new product. So these are various non-linear optimization model applications. So in this video we are going to look at constructing an index fund. Let us proceed to constructing an index fund problem, right? So the case goes like this. Here basically, uh, if you just for a background, index funds are extremely popular investment vehicle in mutual fund industry. Uh, Indeed, the Vanguard in 500 index fund is the single largest mutual fund in United States, right? With more than $89 net assets in 2009, and right now it may be much more than that. An index fund is an example of passive asset management. The key idea behind index fund is to construct a portfolio that of stocks, of mutual funds or other securities that matches as closely as possible the performance of the broad market index such as S&P 500. So what is given to us is that these are the returns showing here. Uh, 500 index fund is giving us a return of 4.77%, and index is S&P 500, and market return is 4.91. So you see 4.91 was the market return, and this particular index fund gave the investors 4.77%. So very closely. So like this, the index funds works. So here in this particular example, what we are going to look at is that the earlier we have also seen Hawk Financial Services example in my earlier portfolio video. So we are revisiting that Hawks Financial example, and assuming that the Hawks has a substantial number of clients who wish to own a mutual fund portfolio with the characteristics that the portfolio as a whole closely matches the performance of S&P 500 stock index. So in that case, what percentage of portfolio should be invested in each of the mutual funds in order to most closely mimic the performance of S&P 500 index? So if you recollect, there were six different options with the investors, that is foreign stock mutual fund option, IB, that is intermediate term bond fund, and all that. So you can revisit that particular video, that problem, which to understand this further. So these are going to be our variables. That is the proportion of a portfolio we are going to invest in. Foreign stock will be called as FS. Proportion of portfolio we are going to invest in large cap value funds can be also called as LV, and so on. And the scenario which was given earlier also in the earlier video. So this is the 5 year scenarios we are considering. Some of the years are very optimistic, some of the years are very negative. For example, year 5 has given returns in almost everywhere negative and strong negative. So overall returns were minus 10. So S&P 500 returns are given here. In the first year, S&P 500 gave 25% return. In the second year, it gave 20% return. So we want a combination of our investments into this various six mutual funds, which will give us very close to S&P 500 returns in these scenarios. So that is our objective. So basically, what we are trying to arrive at is the minimization of variance between our returns and S&P 500 returns. And as you know, variance is nothing but the square. It is the difference of squares, different squares, which we are going to minimize. So that's why the square term will come into picture. So if you recollect earlier also, we called the first year return for our investments as R1, and this is going to be our first year equation. This is second year equation. These values are coming from here. See, second year 13.12 times FS, 3.25 times IB, and so on. So when you add that, we are calling it return for second year R2, R3, R4, R5. So the difference between S&P 500 and our return is R1 25, R1 minus 25, R2 minus 20, R3 minus 8, R4 minus 30, and R5 minus 10, because S&P's returns are given here and our returns are R1, R2, R3, R4, R5. Right now, the minimizing of this, this particular the deviation of this total deviation can be also done, but normally the positive and negative deviations will work against each other, they will cancel out each other. Hence we always prefer the squaring of those differences, and then the total of such squared differences to be minimized, and hence we are going to be using this particular objective function. So our entire model now will look like this: minimize this squared addition of the differences, the square differences ka addition we want to minimize, subject to all this, where R1, R2, R3, R4, R5 are our returns, and also our FS plus IB and all that together should be equal to 1, because our total investment of the portfolio, because these values are our proportions, so all the proportions together should become 1. And obviously there is a non-negative constant, but because our variables, this R1, R2, R3, R4, R5 are also going to be our variables, they are getting into squares here in our objective function. We need to set up this in our solver as a non-linear formulation, and while solving also in the solver we have to choose GRG non-linear. I have explained that this how to handle non-linear models in solver in my earlier video. Specially, I have made a separate video for non-linear and special video, separate video for integer. So refer to those to understand how to solve this in Excel solver. So when you get this solved, your values are getting like this, that you are going to get a 4.42 overall return. But this is going to be always, you will see, never you will get 4.42, because this is a combined value of the return and probability. But either of this is going to be the reality. Either R1 will happen, R2 will happen, R3 will happen, R4 will happen, R5 will happen. So when R1 happens, you will get 25% return, R2 you will get 18% return, and if you look at the S&P 500, they are also almost on a similar line, 25, then 20, then 8, right? In R3 what we are going to get is 8, 8.97, little bit higher. This is also almost 18.5%. R4 is 30.25 and R5 only minus 8, 8.8. So if you see here also, R4 is 30% and R5 for S&P 500 is minus 10. So we are going to get minus 8 against minus 10, and 30 against 30.21 against 30. So this is how we are going to, our formulation of the fund will be 30% in FS, 36% in LV, 22.6% in SG, and 10.5% in SV, and nothing will in IB and LG. So when you use these proportions, this is the returns you will get in these scenarios. So this is how the index funds are constructed and used. But there is a one more improvement over this, which is a Markowitz portfolio solution, which we will see in another video. Thank you.